Lesson 1-6 Identity and Equality Properties. We learn to recognize and use the properties of identity and equality and to determine the multiplicative inverse of a number. Let's consider this example. According to the graph at the right, the price of Super Bowl tickets increased by $0 from 1975 to 1977. Also from 1981 to 1983, ticket prices stayed at $40, meaning there was also no increase at that time. The open sentences below represent each situation. Okay, you have 20 plus A equals 20 and 40 plus A equals 40 plus A equals 40 as well. Okay, where 20 represents the ticket prices from 1975, A represents the price increase, and 20 represents the 1977 price. In the same manner, okay, 40 represents the 1981 price. Okay, A represents the increase, and 40 represents the 1983 price. And if you notice in this particular example, the solution for each equation is 0. Okay, Super Bowl ticket prices increase $0 during each time period, which brings us to the conclusion that the equations such as these can be summarized in algebraic terms. The sum of any number and 0 is equal to that number. 0 is called the additive identity. Okay, so it remains identical to the same number. That's why it's called the additive identity, and 0 is your additive identity, which brings us to the first property, the additive identity property, which states that for any number A plus 0 equals 0 plus A, which will be equal to A. So that's the additive identity property. Okay. In the next one, the equations below also represent ticket prices from 1975 to 1977 and from 1981 to 1983. The variable M represents the number of times of increase. So A is the 1975 price. From what we know, this is the 1981 price, 1977 price, and 1983 price. And again, M represents the number of times it was increased. And if you also notice here, the solution for each equation is 1. Since the product of any number and 1 is equal to that number, 1 is called the multiplicative identity, which simply states that in the multiplicative identity property for any number A times 1 equals 1 times A, or simply A. So that is the multiplicative identity. Let's move on to the next property. Okay. In our next property, suppose you purchase a number of Super Bowl tickets for $200 each. If you sell 3 of them at face value for $200, your profit is 0. Following equation describes this situation. Okay. You have 3 times 0 equals P. The number of tickets is 3. And then this becomes your profit per ticket, which is 0 because you sold it at face value. And then the total profit would be P. Okay? Look at this equation. And in this equation, one of the factors is 0. And the value of P is 0. This equation suggests the following property. The multiplicative property of 0 simply states for any number A, such that A times 0 will always be equal to 0. Simply put, anything you multiply with 0 will be equal to 0. Okay, let's talk about the next property. 2 numbers whose product is 1 are called multiplicative inverses or reciprocals. Okay, 0 has no reciprocal because any number multiplied by 0 will never be equal to 1. It will always be equal to 0. So we go to the next property of reciprocals, which simply states for every non-zero number A over B, where A and B is not equal to 0, there is exactly one number B over A, such that A times B over A will be equal to 1. That is the multiplicative inverse property. which brings us to example 1. Okay, name the multiplicative inverse of each number or variable. That assume that no variable equals 0. So if we have 5, a number that we will multiply with 5 to get the product of 1 would be 1/5. Since 5 times 1/5 equals to 1, okay, 1/5 is the multiplicative inverse of 5. In x, since x times 1 over x is equal to 1, 1 over x is the multiplicative inverse of x. Okay, it says here x should not be equal to 0. Okay, and it's asking why. It goes back to the first commandment of math: thou shalt not divide by 0. Okay, it is illogical to divide anything by 0, or else the number would be undefined, and that's the reason why x should not be equal to 0. Example C, you have 2/3. So using the property of multiplicative inverse, okay, the reciprocal or the multiplicative inverse of 2/3 is 3/2. Why? Because if I get 2/3 and I multiply that by 3 over 2, okay, the product would be 1. Okay, let's take a look at the next property. Okay, at the beginning of the algebra class, Ms. Escalante gave each her students a single strip of paper 8 inches long. She instructed the students to divide their paper strips any way they wished. Okay, Stacy left her strip at 1 8-inch strip. Okay, that's Stacy's strip. Ahmad cut his strip to form a 6-inch strip and a 2-inch strip. And Liam cut his strip from a 5-inch strip and a 3-inch strip. Okay, using the strips of paper, we know the following to be true: that 8 is equal to 8. 6 plus 2 is also the same as 6 plus 2, and 3 plus 5 also the same as 3 plus 5. Which brings us to the reflexive property of equality, which says that any quantity is equal to itself. So the reflexive property is simply saying that for any number A will always be equal to A. Okay? Think of the reflexive property in terms of the word reflection. Okay? It is always the same. Next property we're going to talk about: many mathematical statements and algebraic properties are written in if and then form. In an if and then statement, the hypothesis is part following if, and the conclusion is the part following then. Okay, look at this one. If 8 equals 6 plus 2, then 6 plus 2 equals 8. Okay, where in this case, the hypothesis is 8 equals 6 plus 2. Conclusion is 6 plus 2 over 8. On the bottom part, if 3 plus 5 equals 6 plus 2, then 6 plus 2 equals 3 plus 5. You have a hypothesis and you have a conclusion, which brings us to the next property. The symmetric property of equality says that if one quantity equals the second quantity, then the second quantity also equals the first. The symmetric property of equality simply states that for any numbers A and B, if A is equal to B, then B is equal to A. Okay? Next property. A third property can also be shown using paper strips. Okay? If 3 plus 5 equals 8 and 8 equals 6 plus 2, then 3 plus 5 equals 6 plus 2. Okay, makes sense, right? If 3 plus 5 equals 8 and 8 equals 6 plus 2, then 3 plus 5 equals 6 plus 2. Okay? So you want to identify the hypothesis and conclusion in each statement. This is your hypothesis, okay? And this is your conclusion right here. these two are your hypothesis, and the equation after them will be your conclusion. Okay, if 8 equals 3 plus 5 and 3 plus 5 equals 6 plus 2, and 8 equals 6 plus 2. Okay, again, switching it around but still the same. This is what we call then the transitive property of equality. It says that if one quantity equals the second quantity and the second quantity equals the third quantity, then the first and third quantities are equal. Okay, for any numbers a, b, and c, if a is equal to b and b is equal to c, then a is most definitely equal to c. Okay, so that's the transitive property of equality. Next property, okay, we know that 5 plus 3 equals 6 plus 2. Since 5 plus 3 is equal to 8, we can substitute 8 for 5 plus 3 to get 8 equals 6 plus 2. Okay, the mere fact that we use the word substitute, okay, gives us more, okay, about this property. This is called the substitution property of equality, which simply states that a quantity may be substituted for its equal in any expression. Okay, which states that if a equal to b, then a may be replaced by b in any expression, just like what we have here. 5 plus 3 is equal to 6 plus 2. And since 5 plus 3 is equal to 8, we can substitute 8 to 5 plus 3. So that becomes 8 is equal to 6 plus 2. Okay? You can use the properties of identity and equality to justify each step, okay, when evaluating an expression. Let's take a look at example number 2. Finally finish this lesson. The Pep Club at Roosevelt High School is selling submarine sandwiches, lemonade, and apples at the district swim meet. Each sandwich costs $2 to make and sells for $3. Each glass of lemonade costs 25 cents to make and sells for $1. Each apple costs the club 25 cents, and members have decided to sell apples for 25 cents as well. Write an expression that represents a profit for 80 sandwiches, 150 glasses of lemonade, and 40 apples. Evaluate the expression, indicating the property used in each of the steps. First, we have sandwiches sold for a profit, which is 80. Okay. Sandwiches sold will be 80, and the profit would be $3 minus $2. Why? Because they sell it for $3 and it only costs $2 to make the sandwiches. And then we added to lemonade. Okay, lemonade sold would be 150 glasses. The profit would be $1 minus 0.25 because it costs only 25 cents to make the lemonade and they sell it for $1. The difference would be the profit. And lemonade and apples sold would be 40, and since there is no profit, they chose to sell the apples at the same price they bought it, so 0.25 minus 0.25, okay, multiplied by the number of apples. Okay, and that becomes your expression. And then looking at this carefully, okay, we substitute 3 minus 2, which is equal to 1, substituting the expression 3 minus 2, which is 1, and substituting 1 minus 0.25, which is 0.75, 0.25 minus 0.25, which is 0. Next step, okay, is identity property of multiplication. Why we multiplied 80 times 1 gives us 1, identity property of multiplication. Next step, okay, again substitution, because we multiplied 150, we substitute the value of 150 times 0.75 to be 112.5. Okay, next step would be the zero product. or zero property, or multiplicative property of zero, where anything multiplied with zero will give you zero. And again, the substitution property will apply because now 80 plus 112.5, okay, is the same as 192.5, and that's the substitution property of equality, okay. And finally, the identity property, okay, which simply states that anything you add with zero will be identical to the same number. Therefore, in this case, the club would make a profit of $192.50. Okay? Finally done with our lesson, and on Google Forms, type a summary of what you've learned by responding to the objective of the lesson. Type of question you might want to ask in class about this lesson. Thank you.